Welcome to this IBML online course. This training is designed for field technicians assigned to service and maintain the ImageTrack Series 6000 scanners. However, please take note that this course is for general information only and should not be used as a guide for replacing parts or installing upgrades. Please refer to the ImageTrack Series 6000 Hardware Reference Manual for more detailed information. In this course, you will learn the purpose of the Real-Time Transport Controller, commonly referred to as RTC, the real-time operating system associated on the RTC, and how the RTC communicates with the ImageTrack. For safety purposes during this lesson, the ImageTrack has been turned off and the power has been disconnected from any outlets. All the covers have been removed so the internal components can be seen. So let's begin. First, let's define and identify the purpose of the Real-Time Transport Controller, also referred to as the RTC. The components that make up an ImageTrack scanner must work together to ensure documents are transported, data is collected, which includes ICR, barcodes, mica, capturing, and so forth, and documents are sorted properly. The ImageTrack must complete many internal processes from the time it is turned on to the time the system is ready to operate. These processes must occur to make intelligent scanning possible for information to be captured properly. Now this brings us to the purpose of the RTC. The Real-Time Transport Controller must initialize before the track is operational, as it controls the scanner transport. To do so, the RTC runs an operating system called VxWorks, which controls all timing and track operations. It assigns a document identification number, a doc ID, which is used to track documents as they move down the track. It communicates with the ImageTrack using networking cables, all of which we will discuss more later on in the course. As we mentioned earlier, many processes occur to enable intelligent scanning. When scanning documents using the ImageTrack, a document crosses over a number of sensors as it moves along from one module to the next. These different modules are discussed in Course 3, but let's continue. A document moves along the registration module and soon passes over a second sensor and then a third. Once the document crosses the third sensor on the registration module, a document ID or doc ID is assigned to that document. This ID is used to track the document's progress as it moves down the track. Now that we have defined and identified the purpose of the Real-Time Transport Controller, let's discuss the operating system associated with the RTC. The RTC runs an operating system called VxWorks that controls the timing and all track operations. This system must first complete a boot process and check the track for installed modules before the ImageTrack is ready for operation. Once this system is loaded and then booted, the RTC then polls the ImageTrack by way of the single-board backplane boards to find which modules are present, where they are, and what options are installed. Once this step is completed, the ImageTrack can continue other executions. As a side note, when a user starts an application within Capture Suite, a software client known as the image server executes as well. Once executed, it polls for image compression boards and monitors their status. This will be discussed later on in this course. The image server then connects and establishes data communication between the host PC and the RTC as primary ImageTrack applications may be started. Once the image server establishes communication with the camera boards, it goes into a ready state. All of these steps must be completed successfully, known as the boot process of VxWorks, and check the track for those installed modules we mentioned earlier before the scanner is ready for operation. Finally, it is important to distinguish how the RTC communicates with the ImageTrack. As we mentioned earlier in the course, the Real-Time Transport Controller communicates with the ImageTrack using cables. The RTC uses a combination of Cat5 networking cables and IBML-designed interface boards. Each module has a backplane board that has both an upstream and a downstream connector. The Cat5 cable is used to connect each of these interface cards, one after another, until the end of the track is reached. The interface board then communicates the type of module connected by the rotary switch and address switch settings. These switches tell the RTC what type of module is present and where it is located. They are labeled SW2 and SW3 and are visible from the back of the machine. As you can see here, the SW2 is on the left and the SW3 on the right. There are also dip switches, which tell the RTC what options are installed on the module, if any. These options include the barcode reader, micer, inkjet printer, etc. For more information on how these switches should be set, please view the Hardware Setup section within the Hardware Reference Manual. So when starting up, users first turn on the host PC, log into the specific network account, and then start the image track scanner by switching the power button to on. During this time, the RTC initializes through each of the processes we have examined in this course before the track on the scanner can become operational for documents to be captured, information gathered, and sorted properly using the image track scanner. This concludes the course. By now, you should feel comfortable with identifying the real-time transport controller and have a good understanding of how the RTC communicates with the image track and how the documents move down the track through the use of the RTC. It's time to test your knowledge. The next portion of the training consists of a 10-question quiz. When you are ready to begin the quiz, click Continue.